guys, your friend Jim here with another video. As you saw by the intro there, in this video we're going to talk about the throttle body actuator, throttle body assembly. Throttle body assembly on the Mitsubishi Montero is what they call a fly-by-wire type system, meaning that the computer controls the throttle. We don't have a cable connected to the accelerator pedal. The accelerator pedal is a sensor telling the computer what to do to the throttle, and then there's a TPS inside that actuator relaying to the computer the information, confirming that it did what the accelerator pedal told it to do. Anyway, we'll get into all that stuff right now. But anyway, here's the throttle body. I have an extra one here, throttle body assembly right there. I got this one from the junkyard the other day. So we're gonna go over this. There's a little motor in here, and there's a TPS, a potentiometer, like a dual TPS. It's got a main and a sub. We'll talk about that stuff right now. And then also we're gonna talk about the possible DTCs that's set when that item malfunctions. There's a few DTCs that will set that relate to the circuitry, to the TPS, to the actuator, to a bunch of things. So we're gonna go over each one of those DTCs, and we're gonna go over what possible causes are possible situations are causing those DTCs. Now, this system, there's a few unique circuitry items that I want to point out that I think are important for you to understand if you're diagnosing one of these circuits. So let's get into it. Grab a cold beverage, sit back, relax, and let's get into it. All right, hang tight. All right, guys, so here's the Montero right here, sitting pretty. Look at her. All right, so here, as I mentioned, here we have the throttle body right here. This is the actuator. This is the connector. Very easy to get to. It's a 6-pin connector. We have 4 wires here, and we have 2 down here. You can tell the difference in the wires because the 2 lower ones, which is a green and white and a green and yellow right here, those are a little bit thicker than the first 4. So these 2 lower ones are for the actual little motor in here, and the other 4 are for that TPS, that dual potentiometer type TPS. And we'll go over which one's the ground, which one's the 5-volt reference, checking ohms on the actuator and stuff like that. So let's go, before we get into this, let's go and look at the circuitry on the paper, and then we'll just talk about it and then come back with a voltmeter and check these items out right here. All right guys, so here we have the wiring diagram right there. So in this diagram, as you can see, we have the actuator set up right here. We have the actuator throttle position sensor, and then they labeled it on the diagram throttle position sensor connector P05, but we also have the actuator here, the little motor. So here we have the TPS, and we have 2 potentiometers. We have a sub, and we have a main, and then we have the 5-volt reference. We have a 5-volt reference, and we have a ground. Now, one unique thing that you notice on this wiring diagram about this system is that we have a radio frequency shield. You see this little line here? It's basically a shield going over the harness, and it goes to ground right here. And that ground right there, it's on the like on the side of the dashboard on the passenger side. It's ground number 9. But we have this shield to prevent any interference, radio interference with the signal between the computer and the TPS. Computer needs to know exactly where that TPS is, because as I mentioned before, the computer is relying on the accelerator pedal position sensor to move this guy, and then it confirms that it did what it needed to do by these 2 wires, the sub and the main, these guys. And so there you go. So the computer basically controls the throttle actuator via these 2 terminals, and then it has the TPS confirmation. Now, the other interesting thing that the computer needs to control this guy is power supply. So the throttle actuator has a unique power supply for the throttle actuator. So there's a throttle actuator control motor relay right here, and it gets power from the regular MFI relay, this guy here, and then the computer grounds this relay, grounds terminal number 2 of the relay in order to get power on terminal 132 at the computer, and the computer uses this power supply specifically specifically for the actuator, the throttle body actuator. So this is where the computer gets power from, that it's going to use to activate that actuator. So if we have no power here, or we lose power here, computer will not be able to trigger the actuator. Okay, so that's the power supply for the actuator. It goes into the computer, and the computer, inside the computer, it uses that power supply for the actuator. That's an important point, because we need to, if we have an issue with the throttle actuator, we have to make sure we have power right there. Okay, so just the same way that the computer has an exclusive power supply for the actuator, it also has a exclusive ground. See these two grounds at the computer, terminals 144 and 145, are grounds that the computer uses specifically for the throttle control actuator. So, and then these grounds go through this junction box, and then it goes to ground right there. So that's the computer uses, again, the computer uses these grounds to provide ground for the actuator. If we have a bad ground here, any of these guys, then the computer's gonna have a hard time activating this guy. Okay, so a lot of times when you have no throttle response or lack of power because of the throttle not opening, then that means that, could possibly mean that the computer either has low power supply or low ground that are exclusive to the throttle actuator. All right, let's move on here. All right, I got the lens here, the close-up lens, which if I just use it like this, it makes me look like Gollum from the Lord of the Rings. But anyway, check it out. So basically, we have an exclusive, like I said, we have an exclusive power supply for the actuator, which is right here. The computer controls this relay, throttle actuator control motor relay. It's right there, and I'll show you where it is here on the engine compartment. The computer grounds terminal 15 of connector D32, and it receives power on terminal 132 of connector D136. And that's the power supply the computer uses for that guy right there. This. Okay. So this relay is, if you remember my video for the fuel pump relays, it's right in the same location. So you remove this little cover. Get this out of the way. Come on. Okay. Get that out of the way. And then, as you remember my fuel pump relay video, fuel pump relay number 1, fuel pump relay number 2, and the throttle actuator relay is this guy right here. So this is the relay that sends power to the computer, that the computer uses exclusively for the throttle body actuator, throttle actuator. So let me remove this guy. We'll check some voltages there. We'll go through the diagram real quick. That way you can have that information and you can reference to it. Okay, so I got the relay out. Let me, here's the relay terminals right here, and here's the relay. It's exactly the same as the fuel pump relays that I had mentioned before, so you can see right there. All right, and then according to the diagram, remember what we had talked about, there's the relay connector. There's the relay connector right there. So we have the 4 terminals of the relay. So here we are. Here we have them here. Let's see, move this out of the way. So we have the 4 terminals. But remember, when you look at this diagram, you have to look at it as if this. See how it's got terminal 1, 2, 3, 4. Well, terminal 1 is going to be this one. Terminal 2, 3, 4. You have to give this like a 180 as if you were looking at it from the opposite direction. So in theory, terminal number 4, this red wire is the one that comes from the MFI relay, but the white and black terminal number 3 comes from the fusible link. So the white and black, in theory, terminal number 3 should always have power, which is this guy right here. So let's check the voltage on that and see if that's correct. So let's see. Camera's right there. Got the voltmeter. So we have, put it on voltage. Check terminal. What we know it's terminal number 3, and we have 12.7 volts. 12.7 volts right there. Okay, so that power, that terminal always has power because it comes from the fusible link. So this guy always has power, the black and white. We can't see the wire color, we can only see the terminal number, but we know that it's terminal number 3, and we know that based on my previous video, that's not terminal number 3, this is terminal number 3, because you're looking at it from the other side. So now if we were to check all of these and check everything else out, when you turn the key on, the computer activates the MFI relay, and then at that point terminal number 4 gets power, and then the computer grounds terminal number 2 to activate this relay, and then it receives power out of terminal number 1. We're not going to go over all that stuff, but if you had an issue with your throttle not responding, or anything related to the throttle acting up like that, you would definitely want to diagnose the circuit, make sure the wiring is making it from point A to point B, stuff like that. The computer is really good at setting DTCs when it detects a problem with this circuit. So the best thing to do to get a direction on where to go is to actually pull the DTCs and see what the computer's telling you. So all right guys, so here we go. So what we're going to do now is we are going to check the voltage on these 6 wires here. Now this is just so we can get normal readings, normal throttle actuator readings, and I'm gonna write them down, terminals 1 through 6 right here, and it's gonna be key on, engine off, wide open throttle, and key on, engine running. So we're just gonna write the normal results. We'll go over them later on the bench, and that way if you need it for reference purposes, if you're working on your car, you know what normal readings are. So let's get into it. Alright, so let's go over these readings on the bench over there, and then we'll talk about the DTCs as well. Basically the set criteria for the DTCs. Alright, stand by. Alright, so terminal number 1 is basically the main output. The TPS, as you know, the TPS has a main and a sub. So this would be the main. The main goes from 0.6 and it gradually goes up to 4.2 at wide open throttle. Terminal number 2 maintains 5, that's the 5 volt reference to the TPS, so that's basically normal right there. Terminal number 3 would be the sub. The sub starts at 2.6, it goes to 4.6 at wide open throttle, and then it goes back when the throttle closes again. It goes back to 2.6. So I just did it key on, engine off, and key on, engine running at idle, just for comparison purposes, but it seems to be basically the same until we get to the actuator side. The terminal number 4, the ground, we have a very small amount of voltage. We're checking the voltage drop on that, and it's a very small amount of voltage, so that would be okay. Terminal number 5 and terminal number 6 also are the 2 wires for the throttle actuator. They call it actuator control motor, but on the diagram it looks just like a little coil, and obviously a motor is a coil as well, but I'm not exactly sure what that component is doing inside. I don't know if it's like some kind of magnetic field that the computer is controlling to control the throttle, or an actual stepper motor. Not 100% sure. Anyway, that one had key on, engine off, 12.2 on one terminal and 10.6 on the other one. The wiring diagram does not specify which one's positive, which one's negative. It just has 2 wires going from the computer to the throttle body, to that little coil inside the throttle body. Wide open throttle, again, wide open throttle, but the engine off. 10.4 and 12.2. Key on engine running at idle, we have 13.7 on terminal number 5 and 12.3 on terminal number 6. It did vary on terminal number 6 a little bit. It went from 12.3 to 12.6, somewhere around there. So this is basically, you can reference this. This would be basically normal readings for the 2004 Mitsubishi Montero 3.8 liter engine. It's probably exactly the same between 2003 and 2006. So, all right, let's move on to the next section here. All right, so on this step here, what we're gonna do is we're gonna go over the ohms on the TPS and also on the actuator. Now the actuator, we already measured it earlier. We had 2.0 ohms. Specifications on this little actuator, according to the repair manual, it's 0.3 to 100 ohms, which is a weird spec, because if you were at 0.5 you would still think that there's something wrong with it, but the spec is 0.3 to 100. But anyway, so if you can see in here, we have the four terminals. I'm sorry, we have the 4 terminals that, I don't know if you can tell on the camera here, but they're gold in color. 1, 2, 3, 4, and then we have 2 that are kind of silver. These 2 are for the actuator, and these 4 are for the TPS. So we have terminals 1, 2, 3, and 4. Now, according to the diagram, terminal number one is the input for terminal number 1, which is this one. That's the input for the main TPS side. And then terminal number 2 is the 5-volt reference, which is right there. Terminal number 3 is the sub output, and then terminal number 4 is the ground. But what we're going to do is we're going to check ohms. We're going to check resistance between these 2 points, terminal number 4 and terminal number 2. So when we check resistance here, it'll give us total resistance between this resistor and that resistor. How many ohms do we have between 2 and 4? That will give us total resistance. And then we're going to go between 2 and 3. That'll give us this side of the potentiometer, and then 3 and 4 will give us this side of the potentiometer. And then 1 and 2, this side of the potentiometer, 1 and 4, this side of the potentiometer. So I'll write the results right here to see what we get. So let's start with total 2 and 4. All right guys, so what I did is I set up the meter so we can actually look at the reading. So between terminals 2 and 4, which is total resistance, we have 2.89k ohms. 2.89k ohms. All right, and I'll write it down on the side, and then I'll transfer it to this piece of paper. So total resistance 2.89k. Okay, so now we're gonna go to the sub, the right side of the potentiometer, which is between terminals 2 and 3. So we just move this to 3, and that gives us 168 ohms. So 168 ohms, not 168k, not 168 nothing. So we just have 168 and the little ohm signal right there. All right, so now we're gonna do the left side of the sub, which is between 3 and 4. So just move this to, or I could just move the black to 4. That's fine. All right, and over here we have 3.0k, 3.0k, 3.0k ohms. So 3,000 ohms basically. All right, so now let's go to the right side of the main, which is between terminals 1 and 2. Let's see what we got over here, and we have 175 ohms. Now let's do the left side of main, which is between 1 and 4. So leave that on 1 and then go to 4. And we have 3000 ohms. 3.0K. 3.0K. Alright, so they both have the same amount of resistance on each side. Okay, so that's good to know, I guess, if you're suspecting that maybe there's something wrong inside your throttle body assembly, inside here, then at least now you have these numbers where you can actually see what's normal. Now, earlier I was checking the resistance as I just did right now, and I opened the throttle manually by hand just by pushing it with my finger, and nothing changed. So I'm not sure if it has to actually move electronically in order for the TPS in here to change, but if you just move this butterfly manually, that does not make a difference on the resistance. So alright guys, so let's go over some of the DTCs, and we'll just go over the list of the ones that we're going to talk about, and then we'll go more into detail as to what's the criteria the computer uses to set the codes. So basically the first ones we have here are P0122 and P0123. These two codes are pertaining to the main throttle position sensor, and one of them is a high input and the other one is a low input code. And I'll get into some of the numbers in a few minutes here. Alright, and then the next ones are P0222 and P0223. And those are pertaining to the TPS sub circuit. One of them is high and the other one is low. So high and low. And then we have P0638, P0642, P0657. 638 is throttle actuator control motor circuit range performance. 642 is throttle position sensor power supply. 657 is throttle actuator control motor relay circuit malfunction. Okay, and then the other ones we have P2100, which is pertaining to the throttle actuator control motor circuit open circuit, and the other one is the P2101, which is throttle actuator control motor magneto malfunction. So that's probably like the coil, the little circuit coil inside the actuator. And the next one is P2102, which is throttle actuator control motor circuit shorted low. 2103, throttle actuator motor circuit shorted high. 2108, throttle actuator control processor malfunction. So those are the DTCs, and one thing that you can tell on all these DTCs is that they all have the little asterisks on there. And remember, I don't know if you remember from one of my previous videos, that little asterisk means that the computer is continuously monitoring that particular circuit. It's not that it's going to wait for the next drive cycle or the next key cycle. No. Every time the key is on, the computer is monitoring that circuit to see if it goes out of range. Goes out of range, sets the code. It doesn't give like a pending code and then a hard code. No. The problem happens, computer sets the code, turns the check engine light on. So that's what that asterisk means, that it's a continuous monitor type of situation here. All right, let's move on. All right, so now that we talked about the possible DTCs on this throttle actuator circuit system, now let's go into a little bit of detail for each of the DTCs. So in this case, we have the P0122 throttle position sensor main circuit low, and that's basically talking about the main TPS output going into the computer, and the P0122 sets when that particular signal is low, and the numbers they give us are 0.35 volts or less for half a second. So if it goes for half a second, then that means that the computer will set the P0122 if it drops below 0.35. The next DTC is the P0123. P0123 is for the same sensor signal, the main TPS signal, and now it's for high input. So if the computer detects that that signal is a little bit on the high side, 4.8 volts or more for half a second, then it will set the P0123. All right, and the next one is throttle position sensor sub-circuit low. So now basically same type of code as the P0122, but now we are talking about the sub, not the main. And specifications are a little bit different on this one because the computer will set this code if the sub signal goes 2.25 volts or less for 0.5 seconds. And then we have the P0223, and the P0223 is pertaining to the sub as well, throttle position sensor sub circuit high. And the high side has the same spec as the main. It'll set the code when it's 4.8 volts or more for half a second, 0.5 seconds. And now we have the P0638. P0638 is when the computer detects a difference between it says difference between throttle position sensor main output voltage and target throttle position sensor main voltage if it's 1 volt or higher. And this is basically this DTC is similar to one that we're going to hear later on, but it's basically the computer's also comparing the throttle position sensor to the accelerator pedal position sensor. Because basically with the accelerator pedal position sensor, you're telling the computer where you want the computer to put the throttle, and the computer's confirmation, the computer will get the input from the accelerator position sensor. It'll trigger the actuator in the throttle body, and it'll get confirmation back from the TPS confirming to the computer that it is where you requested it to be. And if if those two signals are off, then the computer will give you a P0638. So again, we're talking about the throttle body and TPS here, but the accelerator pedal position sensor also has a little bit of influence with some of these DTCs. So keep that in mind when you're diagnosing. Later on, we'll put out a video regarding the accelerator pedal position sensor. All right, the next one is P0642. P0642 says throttle position sensor power supply. I'm thinking they're talking about the 5-volt reference on this one, because they do say judgment criteria, throttle position sensor power voltage should be 4.1 volts or less for 0.5 seconds. So if we lose the 5-volt reference, then basically it'll give you the 642. Okay. The next one, we have the P0657, and this one is pertaining to P0657 says throttle actuator control motor relay circuit malfunction. So this is one of the ones that we had mentioned before, situation where the computer grounds this circuit to activate the throttle actuator control relay, and it does not get a feedback that the relay actually came on, and that will give you the P0657 code. P0657. And this explains a little bit more about that, and basically if it triggers the relay and the voltage is less than 4 volts, then it'll set the P0657. And the other thing about this is that it's got some location component locations here. So remember on my other video, fuel pump relay number 1 is here, fuel pump relay number 2 is here, the throttle actuator relay is right there in the middle, but the relay next to that would be the MFI relay. So, and then obviously the computer is right here on the passenger side of the dash. So all right, the next DTC is the P0100, and this one says throttle actuator control motor circuit open. So it's talking about the little motor inside the throttle body, the little actuator, and it's basically detecting an open circuit. Now, on this DTC, they provide us with this circuit, which they also include the ground. So I'm thinking if we have a bad ground, then maybe the computer will trigger that code, and it's kind of looking at that circuitry to determine if it's an open circuit. The ground, it's a terminal at the computer on connector D136, terminal 144 and 145, but they go through this ground junction connector D14, and as you can see, D14 is right there. It's on the passenger side of the dashboard. It's a connector, and you can see the ground. It's got the two wires, and then it goes to ground basically through that junction box. So if you have this DTC, I would look at that ground. And when it sets to that code, basically it's got no current flow, 0.1 amps or less for 0.72 seconds. So if it's activating the actuator, the motor in the throttle body, but there's no current flow going through there, then it assumes that there's an open circuit and it can't push current flow through there. Next one is the P0101. P0101 says throttle actuator control motor magneto malfunction. So this one of the things they're talking about is basically the computer has detected a malfunction with this coil. I'm thinking the way it operates is the computer controls power and ground back and forth here depending on what polarity it wants this magnet to be. You know, when you have current flow through a coil, it turns into a magnet. That's basically how a relay works. So if the computer has the ability to reverse polarity, and that's to control this magnet depending on which direction it wants to go, then whenever it detects a problem, then the computer will set the 2101. Now the set criteria is a little bit of a mystery, because it says to set the code, it says the coil temperature of the throttle actuator control motor should be 356 degrees Fahrenheit or higher for 0.8 seconds. So somehow through its circuitry, the computer has the ability to detect if this coil is overheating or not. It's got some high-tech stuff going on in there that they don't tell us about. They keep it basic here on some of this explanation, but I know that there's some high technology out there that some of these electronics have the ability to do that. So that would be the P2101. Okay, moving on, we have the P2102. 2102 says throttle actuator control motor circuit shorted low. So it's detecting a short basically in here. So not detecting overheating, but it's detecting a short circuit. Basically, it's doing, it's monitoring the amperage going through it, and if it detects 12 amps or more for 0.8 seconds, then it deems that actuator is shorted out. So 12 amps would be a little bit too much. It would think it's a short, and it'll give you the 2102. So that would be the shorted low. Now, just like this code, we have another code that's the 2103. Now the 2103 is shorted high. Throttle actuator control motor circuit shorted high, and it's basically the same thing. Certain amount of amps went through here that the computer was not expecting, and it set the shorted high. So the difference is, to set this DTC, the 2103, the computer has to detect 8 amps or more for 0.8 seconds. The other DTC, 2102, is 12 amps or more. So I'm assuming if there's an issue, it'll set this code first before it sets the other one. So that's the 2102, 2103. Okay, and then the last but not least, we have 2108. 2108 is It's like the first one that we were, one of the, not the first one, but one of the other ones that we were reading, where the computer compares the accelerator pedal position sensor main, compared it to the throttle position sensor main. So again, the accelerator pedal position sensor is the boss. That's basically telling the computer what you, the driver, wants the computer to do with the throttle. The computer will send the signal and get confirmation back on the throttle. And if the accelerator pedal position signal and the throttle position sensor, if both of those are more than 1 volt apart, then for 1 second, then the computer will give you the 2108. So that would be the throttle actuator control motor module processor malfunction. And again, accelerator pedal position sensor is also part of this setup. So if you have any of these DTCs, that's one of the things that you should also be looking at. Accelerator pedal position sensor inputs and outputs. Let's see. Okay, so that's it for all these DTCs. We went through the list. We went through some of the details, and let's keep moving forward here. Alright guys, so this pretty much concludes the video. Thank you so much for watching. Greatly appreciate it. Please like, share, and subscribe to my channel. Share this video with your family members, your friends who might own a Montero or are interested in owning a Montero. Let them know about the Mitsubishi Montero channel. I'll be putting out more videos in the recent days here, in the next few days. So just also all the documents that I used today, all that stuff, I'm gonna scan all that stuff and I'm gonna put it I'm going to upload it to the Mitsubishi Montero Gen 3 Facebook page. I'll put them on their files. You'll see them once you search for them on their files. So I'll put all that stuff up there. That way, if you have an issue or you want to reference those DTCs, then you can just go ahead and print them out from there. Anyway, thank you guys so much for watching. Greatly appreciate it. See you on the next one.